Greetings, Year 11 students. Today we're going to begin our journey with differentiation. So let's get straight into some of the terms that you're going to have to understand. First of all, we're going to talk about differentiation or the derivative. If you differentiate, you have found the derivative. So you'll see the word derivative there, and you'll hear me talk about differentiation and differentiate and find the derivative. They're all the same concept. Now, the derivative is a process, or finding the derivative is a process whereby we can actually find out what the value or the gradient of a tangent is on a curve. So let's just break that down for a second. If I have a curve, there you go, there's my random curve. When I look at the curve, I can actually look at it and see, wow, from left to right, I'm going uphill, I'm going uphill, I'm going uphill. I've got a positive gradient, but it's continuously changing because I'm flattening off. So my gradient is continuously changing. And using the derivative, I can find the gradient of the tangent at any point in time along the curve, whether it's negative or whether it's going uphill, positive. So the derivative is allowing me to find the gradient of the tangent at any point on any curve, effectively, as long as it's smooth and continuous, and we'll talk about that later. So, the derivative of some function y equals f of x, when we were talking about finding a derivative, we can write it as f dash x. It's actually pronounced f prime x, but most people call it f dash x. Y prime, or y dash, or dy over dx, the derivative of y with respect to the letter x. Three different ways that we can abbreviate the fact that we are about to find the derivative, about to find a rule that will give us a slope or a gradient of a tangent. Now, let's just consider for a second the straight line y equals mx plus b. You know the gradient is m, which means that the derivative f dash x is equal to m, or y dash equals m, or dy dx equals m. The derivative is m. If you took a horizontal line, we know that all horizontal lines don't have a gradient. Their gradient is 0. So for horizontal lines, the derivative is 0. F dash x, the derivative, is 0. There's plenty of other graphs that we come across that aren't so straightforward, and we need to be able to understand how to find the gradient of any point on a particular graph. Some language will be useful. If you're talking about a chord is a line segment between 2 points on a curve. A secant is just a line that passes through a curve. A chord is part of the secant. A tangent is a line that touches a point on the graph. It actually doesn't go through the graph around that point. So, let's actually talk about what we're going to do here. On the graph below, and we can see the graph below as a graph of y equals x squared, we're going to use a ruler to draw the tangent at the point 1, 1. Now, I'm not going to use a ruler, I'm just going to freehand it. You need to use a ruler. I go to the point 1, 1, which is there. If I draw a tangent in, I'm going to say my tangent, I think, is pretty much, look, something like this. There's my tangent, I think. Extend it up a bit. I think that's my tangent. Touches the curve at the point 1, 1. Now, I'm going to use rise over run to find the gradient of my tangent to no more than 2 decimal places. Now, yours could be a little bit different to mine. Our tangent that we're drawing in is a guess. I think that's where it is. Now, if I do rise over run, I need to pick 2 points. I'm going to pick 2 points on my line that are workable. That one there looks workable. That looks like it's at the point 1.5, out 1.5, up 2. Maybe I should have gone for that point there, out 2, up 3. Anyway, I'm also going to choose this point here, which I know is 1, 1. If I draw a triangle in, I can go the gradient is equal to the rise over the run, which in this case, the rise, I'm rising from here up to here, there up to there. I've risen 1 unit. I've run from 1 out to 1.5, so I've risen 1 unit and I've run half a unit. And 1 divided by a half, do it on your calculator, works out to be 2, which means my gradient is 2. Now, I'm lucky because the point that I chose was pretty smack bang on there. If yours was a little bit out, and you do rise over run, you might actually end up with a decimal answer, but your answer should be reasonably close to the number 2. You might have got 2 and a bit, you might have got 1.9, you might have got something that was close, but it should have been close to 2. If we look at example number 2, the tangent's actually been drawn in for you. You can see it, it's our red line. So there's our tangent running down there through the point 0, 0. Now, being a tangent at that particular point, that's my attempt at drawing it in. Let's actually use the definition of rise over run. Now, I don't know what the equation of this graph is, don't really care, but I do know it passes through 0, 0. What's another point that I think it passes through? If I went for that point there, that looks like it's at -1, comma, let's see, it goes up to about there, which should be 1.2. So, if I was to draw a triangle in, the rise is 1.2, because I've risen from there up to there. We said it was 1.2, and the run is 1 unit to the left. So the gradient equals rise over run. Be careful with this one because it's from left to right. My line's going down the page or down the graph, so it's a negative gradient. So it's negative rise over run, or -1.2. And that's what I think it might well be. Let's try the process again for question number 3. Okay, we've got y equals x squared there. Now we've got a few tangents there that have been drawn in. Let's go to x equals -3, this point here. Oops, let's just clear that. So this is the point here we're looking at. If I try and find another point, so I'm going to use this point here, another point on my tangent, so there's my tangent, it runs down like this. You can see the red line faintly there. I'm going to use this point here. So I've dropped down and I've gone across. Now the rise, if I look at it, I've gone from there up to there, which is equivalent from 0 up to 9. So the rise is 9. And the run is from -3, that's -1.5, that's 1.5. So the rise over the run is 9 over 1.5. Now if you do 9 divided by 1.5 on a calculator, it will give you 6. But remember, it's going down the page from left to right, so -6 is the gradient when you're going to the point where x equals -3. So I'm going to clear all of that, and then I'll put -6 6 there. If I go to -2 and do the same thing, I'm going to look at -2, so I know that point there, but I haven't drawn a tangent on. So if I actually draw a tangent in and find the rise over the run, plug it all in, I'm going to end up with the answer for -4. You have to trust me on this. If I go to the next point at -1, x equals -1, so there it is there, -1, 1, I could use those 2 points because you can see my tangent coming down here. The rise is 1, the run is 1/2, 1 over 1/2 is 2, and it's going downhill, so it's -2. If you draw a tangent at 0, it's a horizontal line, and horizontal lines have a gradient of 0. If you go to x equals 1 and draw a tangent in, symmetrically it's very similar to this side, and you're going to end up with an answer of +2, not -2. If you go to x equals 2, this point here, and draw your tangent in, this is this red line here, and do the rise over the run, and you could do that here. The rise over the run is 4 over 1, which will be 4, and that will be 6. Now, you can go through the process to get these answers here. Now, we want to actually draw a graph of the gradient answers, not the y values. So we're going to graph the x values compared to their gradient. So the first point we're going to go to is -3, -6. So we go to -3, -6, and we put a dot. The next point, -2, -4. -2, -4. Then -1, -2. Then 0, 0. And similarly, 1, 2, then 2, 4, then 3, 6. Join them, and that is called your gradient graph. Time for you to try doing some questions where you draw tangents, find the rise over the run, and estimate where appropriate what you think the gradient will be at particular points. Enjoy the experience. Bye for now.